Welcome to
Nay.
Do it.
Channel Everyone. Okay, so today we are diving into a paper that tackles a very specific but super common headache in AI, getting large language models to actually follow the rules of a world. JJ, you've worked on agents. Why is this so hard?
It's a fascinating problem, Isabel. Think of it like this. You give a brilliant, creative chef a recipe, but the kitchen has very strict rules. The oven only works if the door is closed. You need to have the eggs in your hand before you can crack them. The chef might know 1,000 ways to make an omelet, but if they don't meticulously track these preconditions, they'll just try to crack an egg that isn't there.
Exactly, and the feedback in these simulated environments is often terrible. The agent just gets a generic "you failed" message. It doesn't know *y, so it starts guessing, takes invalid actions, which pushes its mental model of the world further from reality. This is what the paper calls the degenerative cycle. Invalid actions cause state drift, and a drifted state leads to more invalid actions.
State drift. That's such a good way to put it. So their solution is this system called RPMS, Rule-Augmented, Plan, something.
Memory synergy, rule-augmented memory synergy. The core idea is elegant. You have two sources of guidance for the agent. One is its own episodic memory, what it has done and seen. The other is a set of explicit, structured rules about the world, like you must be holding an object to use it.
And the key insight, which I think is brilliant, is that these two sources can actually fight each other. Your memory might say, "Last time I was in the kitchen, I used the pan." But the rule says you can only use the pan if it's clean. If you just follow memory, you fail.
So RPMS has to be the referee.
Precisely. It uses a rules-first arbitration. The explicit rules get priority. Before the LLM even suggests an action, RPMS retrieves the relevant rules for the current situation. It uses those to filter the agent's own memory. Only memories that are still valid given the current state and rules are considered. This creates a gated, conflict-managed plan.
And the results are pretty dramatic, right?
Very, with a smaller model like Llama 3.18b, adding just the rule retrieval part gave a nearly 15 percentage point boost. That's huge. It tells you that a big part of the failure is simply not knowing the game rules, which the LLM wasn't trained on.
And the finding about memory is crucial. Used blindly, episodic memory can actually hurt performance on some tasks. The agent gets fixated on what worked before in a different state. But once you filter that memory through the current state and constrain it with rules, it becomes a powerful positive. That's the synergy in the name.
So it's not about replacing the LLM's reasoning. It's about giving it a better, rule-bound notebook and a fact-checker before it speaks.
Yes, it grounds the agent. The paper also showed this approach transfers to a completely different environment, science world, with consistent gains. It suggests this isn't a trick for one specific game, but a general principle for making LLM agents more reliable in structured settings.
It moves us from pure generative improvisation towards a more managed, structured reasoning process. The LLM provides the creativity and high-level planning, but the RPMS system provides the rulebook and the short-term memory manager.
I love that. It's like giving our brilliant but sometimes scatterbrained chef a meticulous kitchen assistant who whispers the rules and keeps the inventory list. Thank you both, JJ and Zhenhang, for breaking that down.
Thank you, Isabel.
Thanks.
And thank you for watching. We'll see you next time.